So here's our next unit. Okay, we're going to take a geometric approach to some shapes you've worked with before and also some new shapes. So here's how these things are created. So we're going to take these cones and we're going to stack them on top of each other. Circle cuts it plane, exactly parallel to the floor. Okay, an ellipse cuts it on an angle, makes that shape. Parabola cuts it so it goes through the bottom of this cone. And the reason we have the two cones is for the hyperbola, or the hyperbole, however you want to say it. So that has two parabolas stacked on top of each other going in opposite directions. Okay. This guy down here, if you Google image conic sections, and that's really what this whole chapter is about, it's kind of this picture here. So you can see some circles in the middle. They start becoming more elliptical, okay, and then they turn into parabolas. And then here in the middle, you have your hyperbolas. Okay, so kind of different ways that these things cut out. Here's another picture of how these things happen just with the single cone. So circle slices it parallel, ellipse slices it at an angle, parabola slices it so you get some of the bottom. In the hyperbola, you get two parabolas, one top and one bottom. This guy here is from the year 1728. So this is what people were doing, almost 300 years ago. They had these pictures. You can see conics with a K up here. There's some hyperbolas in there, and just different things they're doing and applications with it, or plans for building stuff, because obviously it was almost 300 years ago. So yeah, a lot of cool things there. All right, first shape we're going to look at is.
Jesse Cristofaro, please come to the front office. Jesse Cristofaro.
First shape we're going to look at is the parabola. Okay, so section 9.1 basically just takes you through this picture here, and that's it. Okay, so we'll start here with 9.2, and it's a parabola. So we kind of start with, what do you guys remember about studying parabolas both in Algebra 2 and College Algebra? Well, the only parabolas you guys did opened up, or they opened down. You had two different equations for them. You had standard form, and you had vertex form. The key points were obviously the vertex and your y-intercept. Then we kind of used our calculator to help us get the rest of it. Now we're going to take a completely different approach to these here in this unit. We're going to create a definition for a parabola with this. So it's a collection of all points P that are the same distance from a fixed point, F, we call that the focus, as they are from a fixed line, D, which we call the directrix. Okay? So the distance from focus to the point is the exact same thing as distance, point, to directrix. So this focus and directrix are something new to you. Okay, so every point on a parabola is created this way. Now there's a ton of cool Sketchpad apps with this chapter that I'm going to take you guys into the lab and let you play around with so you can see exactly how these things are created. Okay, so there's your definition. We'll do a couple pictures and then a new formula for us. So here's your parabolas you guys are used to. So something opens up, something opens down. We're introducing this focus here. In this case, it's at 0A, and a directrix. Okay, so every point on this parabola is an equal distance from the focus as it is to the directrix. So these are off a little bit. They got distorted when we clipped them and pasted them, but that's the idea. Every point on this parabola, if this is 10 units, this is 10 units. Okay, if it's upside down, so your focus is now 0, negative A. Your directrix is the same distance behind it. So whatever this distance is here, it's the exact same as this guy here. So if this is down at 0, negative 4, this is 4, that means that's 4 as well. So if you take this point here, it's the same distance to the focus as it is to the directrix. We're going to look at parabolas that open left and open right. So I'm not sure if you've studied those before. but they're no longer going to be x squared equations. They're going to be y squared equations, but same idea. Okay, we now have a focus out here on the x-axis. We got a directrix equal distance behind it, so this is the same as this. And this way, your focus is at -5, 0, so your directrix would be at +5. Here's how we come up with our formula. So by definition, and this works for any of the 4 pictures, okay, these red distances are the same. If I picked this point right here, well, we'll do it in red again. Whatever that distance is, it's the exact same as here. Okay, whatever this distance is, it's the exact same to here. And all these points on the parabola follow that rule. So using what I told you earlier with this, distance focus to point is same as point to directrix, we can create this. So x minus a, so we're going point to focus here. So x minus a, quantity squared, plus y minus 0, quantity squared, equals the absolute value of x plus a. Okay, distance from point to focus, same as point to directrix. If we solve this here real quick, making sure we double distribute everything correctly, I'm going to square this side. I'm going to square this side to get rid of it, so I didn't even copy the square root there. Let's see what happens. X squared each side goes away. 2ax on each side goes away. Oops, sorry about that. We were going too fast here. If this guy's a minus 2ax, it's certainly not going to go away with this guy over here. So we canceled the wrong thing. A squareds go away is what you want to happen. If we add this to the other side, what you end up with is y squared equals 4 times a times x. Now, it's opening left and right, not up and down how you guys are used to. So it's not an x squared anymore, it's now a y squared. And this is how we're going to write it, okay? When you guys graphed these before, you might have done square roots. So you might have had one positive square root and then one negative square root, but we're going to write it this way, okay? A is going to be our focus. So when you're trying to graph these, when you're trying to get equations, you got to think about what is this little guy right in here. Okay, that's going to be our focus. If it's positive, we plug it in. If it's negative, we plug it in as well. But that's how the equation works. Now, what if I want you to find an equation of a parabola, vertex at the origin, so we're going to stay at the origin today to make it easier, and the focus is -2, 0. Whenever you're given one of these, you got to figure out if it's an x squared or if it's a y squared. Okay, so which way is it going to open? So plot this focus, -2, 0. If we know that's the focus, we know the parabola opens towards the focus, so there's got to be a directrix behind it. Okay, so that'll tell us automatically that this is the equation we want to use. Right? Plug in the focus, because this is a comma 0, and let's see what happens. There's the equation of it. That's it. Y squared equals -8x. The negative means it opens in a different direction, just like if I ask you to graph -x squared, it opened down. Okay? So in part 2, we'll pick up with how we're going to graph these guys.